And the topic for today is Azure Traffic Manager, globally scalable DNS routing service. If you're building multi-region applications, this is a perfect service for you. So stay tuned. As always, let's start with Traffic Manager definition. First of all and foremost, it's a DNS-based traffic load balancer. Its main purpose is to distribute the traffic across your services while still providing this high availability and high responsiveness for those applications. So it is a very fast service. And the main way it works is that for each traffic manager, you define something called endpoint, and you will have multiple endpoints behind a traffic manager profile. And when it comes to endpoints, they can be either services within Azure, where you have a lot of additional integrations, or it can be any internet-facing service that you use. Once endpoints are defined, a traffic manager will start routing the DNS traffic to your services based on two things: traffic routing method, which you will be choosing when creating the profile, and additionally a health of the endpoint. As such, traffic manager will periodically check your endpoints so that they need to return a status code of 200 or whatever you will define to make sure that those are running and it is routing the traffic to the services that are up and running. And once the endpoint is chosen, a name service lookup will be returned to the user so that the further communication is established between the user and a specific service. And now we can actually talk about the traffic routing methods, because this is the key part that you will be configuring for traffic manager profiles. First of all, what are the routing methods? The first one is performance-based. So it's the so-called find me the closest endpoint to me based on the network latency. In this example, if you have two endpoints behind your traffic manager, one for North Europe and one for East US, if your users are coming from instance from Europe, they will be redirected to the North Europe web application, and in case of Brazil, they will be redirected to East US, because those are the closest services and service endpoints to them based on that network latency. The second one is weighted. So for each of the endpoints that you have, in a similar example, you establish a weight. And that weight is an integer between 1 and 1000, and based on that weight, traffic will be distributed accordingly. The third option is geographical. While this sounds similar to the performance one, it is quite different, because for each profile, you actually define which geographical locations based on where user actually started their DNS query from should be redirected. In which case you can say, for instance, entire globe should be redirected to my North Europe, but because of some, let's say, legal reasons, I want all my users from US to be redirected to the East US application so that I only process data within the US region. And this is one of the use cases that you would want to use geographical. The next one is priority based. So priority is very simple. For each endpoint you define a priority, and once the priority is defined, all the traffic is actually routed to the highest priority server as long as it's healthy. And later, whenever that endpoint changes to not healthy, all the traffic will be routed to the second highest priority server that still remains healthy. So those kind of routings are usually used to provide a full backup services for your disaster recovery scenarios. And the next routing method is multi-value. In this case, within a single query, your applications are able to get a list of all the endpoints on the backend. But the difference here is you cannot use name server mappings for the endpoints. You can only use IPv4 and v6, and it's up to your client application to do the fallback itself. But it still has some narrow use cases that you will want to use that. And the last one is subnet. So you can actually define the traffic to your backend endpoints based on a subnet definition of your incoming users. So based on their IPs, you can actually define that those users will go to North Europe and the others will go to the other applications. If you don't specify any subnet, this will be the none and the fallback service for all the other traffic. In terms of the additional feature that you also get endpoint monitoring. So a traffic manager will automatically monitor all the endpoints for your backend to ensure that it only routes the traffic to the ones that are healthy. And if your endpoints are within Azure, you get a lot of additional integrations. Also, you can do nested endpoints, so you can actually nest multiple traffic manager profiles in order to take advantage of multiple routing methods within a single manager profile. You also have traffic views, so you can actually view the traffic coming from the wall that goes through your traffic manager. You also have some real-time user measurements, and you have some metric and alerts. All those additional features are also available as part of the Traffic Manager. And for today, for demos, I will show you how to create a Traffic Manager profile. And after profile is created, I will show you the performance, weighted and geographic-based routings for the manager profiles. For today, I will show you how to use a Traffic Manager and also how to test it using 2 VMs within 2 different regions so that we see the differences when connecting to different web applications. But so that you and I don't have to create so much, I created a CLI script that we will be able to execute, and you will have it down in the comments so that you set up your environment within just seconds. So let's go to the portal and start executing our script. Before you execute the script, let me show you what it does. First of all, it creates an Azure Resource Management group called Azure Traffic Manager Introduction, and within this group it will create 2 virtual machines, 2 app service plans within 2 regions, and 2 web applications. At the very last step, it will list those web applications and list those virtual machines. So basically just copy paste the script from the repository, go to Azure Cloud Shell, open the window full screen, and paste it in once the terminal initializes. Right click on the window, paste as plain text, and let it run. After about 5.5 minutes, script should be done, and you should see this output with the addresses for your web applications and the addresses for your virtual machines. So before we go into those, let's minimize this for a second and let's open our resource groups. Let's go to Azure Traffic Manager Introduction and show you what do we have here. Let's enable grouping so it's easier to see, grouping by type. So it still didn't refresh for the second web application, but it will be there in a second. So first of all, you have 2 web applications. Let me just refresh that. Yep. East US 2 and North Europe web application, as you see there in respective regions. And you have virtual machines also in East US and North Europe. So you have this start of the demo where we can test everything. So first of all, what do we need to do? If we go back to the shell, we need to grab this URL for the first web application and paste it in. As you see, this is a starting page. It's empty right now. I also gave you here the address to Kudu, which is the terminal for you to manage the service. So you can actually open it and log into this East US 2 virtual machine and go to the PowerShell. So what we want to do is we want to change this default web page so that it actually says East US 2, so we know which one of the servers is returned by the Traffic Manager. And to do so, we're gonna go to Kudu, go to site, www.root, and here's a hosting start with this default page that you see here. So let's just edit it and paste in the example that I gave you here. For the East US, I prepared a very small HTML for you, just to paste it in, hit save, refresh the page, and as you see, hello from East US 2. So we need to do the same for the second web application. Paste the URL. I missed the T at the end. And paste in the SCM for Kudu. Go to debug PowerShell. Open site, www.root, hosting start, edit, and paste the example for West Europe. Paste it in, hit save, refresh, and it's hello from North Europe. So now we have 2 applications and it will be very easy to distinguish whenever we were redirected by Traffic Manager to East US or North Europe. We also have 2 VMs that we'll be using to test the Traffic Manager. But before we use those, let's actually create a Traffic Manager profile since our environment is now ready to be tested. So let's hit create resource and type Traffic Manager. We need to create a Traffic Manager profile, hit create, and provide a name. I'm gonna call it Traffic Manager Demo. This is taken, so I'm gonna add 1. It's also taken, maybe AM at the end. It has to be globally unique name. The first routing method, I'm gonna choose performance. This is the first demo, but remember you can actually change it post creation. So hit performance, select the resource group that I just created and hit create. So as you see, to create a Traffic Manager profile, you literally just need to provide a name and the initial routing method. And it was created. So let's go to the Traffic Manager, and in here, you can actually start configuring it. As you see, it's currently enabled, so one of the cool things is that you can disable the profile if you don't want to use it. This is the URL that you're going to be using for the Traffic Manager. And currently monitoring status is inactive because we don't have any endpoints defined. So let's start creating endpoints. To do so, go to the left panel, go to Endpoint section, hit Add. We're going to be choosing Azure Endpoint. You have also external and nested, as we were talking about, but since my applications are within Azure, those are Azure App Services. I'm going to choose Azure Endpoint. I'm going to call one East US 2. I'm going to choose the type of Azure service. This is going to be App Service. And the target resource allows me to pick from my existing app services. So in this case, Demo Web East US 2. And just hit OK. After a few seconds, you get East US 2, status enabled, monitoring status checking, endpoint. So it should take about a minute or two for this to be online. And we need to do the same and add an additional endpoint for our North Europe. So let's call it North Europe. Let's hit App Service again. Target resource in this case is North Europe. And hit OK. And now we just need to wait about a minute or two. You can wait here, or you can go to Overview, where you also get the list of your endpoints. Once both endpoints are online, you can start actually testing. Because if I will copy the DNS name, what will happen right now? It will route me based on performance, so the closest server to me. So if everything went correctly, since I'm based in Poland, it should route me to the North Europe. Let's hit open. As you see, hello from North Europe. So this is perfect, and it would be very hard for me to test if this works, because every time I'm gonna refresh this page or every time I'm gonna open a new window, I'm always gonna land in North Europe. And that's why we've set up those two VMs. If we go back to the Cloud Shell here and start copying the paste, let's do something like that. I have a remote desktop connection manager, which I like to use to test remote desktop connectivity. I'm gonna add a server here, and I need parameters from the script. So I need this public IP of the first server to paste in the server name. I need a name in a display name, so paste it here. I need a password, which I need to paste into login credentials into the password section, remove the domain, and copy the username of my administrator account. So hit edit and double click to connect. Accept the certificate and connect. Additionally, you need to do the same for the second one. So let's add another server. Add a server, server name, copy also the name of it, paste the name, copy the password, login credentials, password, no domain, and of course admin user as a name. Hit OK, and also connect to this server and additionally accept the certificate. Since my virtual machine in US2 is almost done, so let's hit OK. Let's close those windows. Those are the first time windows when initializing the VM. So as you see, this is a very clean VM that I just created. Nothing is in here. So what you can do right now is open an Internet Explorer and paste the URL of your service. So let's close this window. Let's paste the URL. Actually, we need to copy the URL again from the Traffic Manager profile and paste it here into the browser URL. And as you see, hello from East US 2. If we're gonna do the same action on our North Europe, we should see North Europe app service responding. So let's close this window again. Let's paste the URL. Let's press enter and see the message North Europe. So as you see, our performance-based routing already works just fine. And let's try a different one. This time let's use weighted routing method. So let's go back to the portal and you go now to configuration, where you can actually change the routing method from performance to weighted. Hit save And once you do it, you will be able to actually go back to your endpoint section. And now for each endpoint, notice that the weight of 1 was assigned automatically. And you can actually change it. But if you don't change it with weight of 1 on both of those services, all the traffic should be distributed randomly equally across those services. So let's actually test that. Let's go back to our VM and let's test this scenario here. And in our VM, it doesn't matter if we're in North Europe or East US right now. If you're gonna refresh this page, you're always gonna get the same one because it's DNS and DNS is being cached. So what you actually need to do in order to properly test this, you need to type cmd for the command line, open Windows Terminal, and inside of Windows Terminal type ipconfig//DNS. Once you do it, you can actually close the browser right now, open it again, and paste in the URL, and try this couple of times to see if your weighted routing method works. You should randomly at 50% chance go to East US 2. As you see, it worked just fine. If you don't like testing with a browser, you can always flash DNS here and try NSLOOKUP, which is name service lookup, and paste the URL here, except remove all the parts that are URL specific because you just want the DNS name. And as you see, we right now got redirected to North Europe. If you're gonna flash DNS again and do name service lookup, again North Europe, do it again, and this time East US. So as you see, it's totally random. And it's as easy as you're right now going here and changing the weight to be able to assign, for instance, 1000. In which case, I should almost always get redirected to East US 2. And go back to the portal and test it here. So flash DNS, NSLOOKUP, North Europe, flash DNS, NSLOOKUP, East US 2. So it right now picked up the configuration. So we pretty much always should go to the... Looks like we landed in North Europe again, so maybe it didn't pick up the change yet. But if you're gonna flash DNS and just do it a couple of times, you're definitely gonna start seeing the pattern of you being dropped into East US time almost every time using those weights. And lastly, let's try one more configuration, in which case this is the geographic type of configuration. Notice that if I will click save, it will actually throw me an error, because you actually need to remove the endpoints before doing that, because currently those endpoints don't have any geo assigned and no geo will be assigned by default. Therefore it fails because the geo is primary and required field, so it fails on the validation. It's pretty silly, but it's just one-time process. So change it to geographic, hit save. Once you saved it, you can go back to your endpoints and start creating them again. Right now, let's choose it again, East US 2. Again, app service, and choose our app service in East US. But notice now you have geo mapping, where you can actually specify that in case of North America, I always want to route people to the East US 2 endpoint. Now I'm making sure that whoever is coming from this region will be automatically mapped. What is cool here is that I can actually nest this further. So I can say from North America, but maybe specifically from United States. So you can make sure that all those mappings are relevant to your application business needs. And add additional endpoint, in this case North Europe. This again is app service, it's North Europe app service. And I can say that entire world, so everyone else should be landing in North Europe. Hit OK. Let's save it and let's see it works. After a couple of minutes it will be picked up and we can go back to our application and start checking it. So let's flash DNS, let's copy the URL, let's close the Internet Explorer, and in case North Europe, I should always land in North Europe. In case of East US 2, remember that I need to flash DNS here as well, so I need to open terminal. And now I can actually open it, and I should be landing in East US 2. And I should be landing in East US 2 every time here and every time here. So if you just flash DNS and do NSLOOKUP, this time, based on the geography, I should always and always and always be landing in North Europe. If I would change this mapping, for instance, if I would say here additionally in Europe, in specifically Poland, let me just find Poland here and hit save. That means if I'm gonna open this URL here, for instance from the Edge browser, I should land in East US 2. Perfect. As you can see, setting up Traffic Manager is quite simple. This is what I like about this service. Within just few minutes, few clicks, you're setting up what is otherwise hard to achieve within Azure, globally available, highly performant service for very low price. You should use Traffic Manager whenever you're building cross-region applications. That's it for today. Hit a thumbs up, leave a comment and subscribe if you want to see more, and see you next time.